Hi everyone, welcome to another video by Maths with Sarah. So today we're going to be tackling this question, which as you can see involves quite a lot of surds. We're going to be rationalising the denominator, we're going to be simplifying surds, we're going to be multiplying surds, adding them, subtracting them, all things surds today in this video. So as with all of these questions, I encourage you to pause the video now, have a think about how you would tackle this question. If you get stuck, don't panic, just come back when you've had a chance to have a think about at least what method you would use to tackle this question. I accept that it is a pretty hard one. Surds, I think, are a challenge for a lot of people, but hopefully I will be able to simplify it for you and make it so that you are able to understand it with no problems at all. So just give you a couple of seconds to have a think about it, and then I'll come back and go through the answer. Okay, so as you can see, this question sits on a non-calculated paper and it's right at the end of the non-calculated paper. So it's question 4 out of 26 or 27. So clearly it's a hard question. And I think just looking at this would probably scare quite a lot of people. It does look really intimidating. But surds are not as difficult as I think they quite often seem. So people are very familiar with algebra because they've been using algebra since they were probably in year 7, if not before. So you become very familiar with it. Whereas surds is something that kind of just gets thrown on you in probably year 11, year 10 at the earliest. And you're kind of expected to understand them. But what you can do with algebra, you can do with surds. It's exactly the same. So, well, exactly the same principle. So that's how I want you to be thinking about this. Is as much as anything, it's algebra, and it's applying the principles of algebra to just a slightly different context. In this case, the surds. So if we look at this question, we've got 2 root 6 over root 5 minus root 3 over root 10. Now, with all of these questions, despite the fact that it's a surd, you've got to use the normal principles of mathematics. So if we were looking at this and it was 2 fractions, if we had, say, 2 root 6 over 5 and root 3 over 10, you would very quickly realise that you cannot do a straight subtraction because the denominators are not the same. So the first task with this, actually, before I do anything, I will just say that there are a number of ways that you can do this question. I reckon every single person will do it very slightly differently. This is the method that I used. I'm not saying it's the right method or the correct method, but everybody will use slightly different methods. So first thing I'm going to do is to subtract this fraction from this fraction, you've got to make sure that the denominators are the same. So in order to do that, let's see if we can simplify out root 10. So we've got 2 root 6 over root 5. Minus root 3 over root 10. Now, if you remember with surds, you can separate out surds by finding 2 numbers that multiply to make them. So this is the same as root 1 times root 10. Not that you'd ever really write that. Root 2 times root 5. And if we write it like that, hopefully this becomes a little bit clearer. So if we write this as root 2 root 5, although obviously for now it makes it a little bit more complicated, it is going to make it simpler overall. So then you can hopefully see that we're starting to get similar denominators, and if we times this fraction here by root 2, we're going to end up with exactly the same denominator so that we can then multiply this fraction out. So if we put this on the top, we can do 2 root 2 root 6. Divide that by, again, we'll put the root 2 in, so we'll have root 2 root 5, and then subtract root 3 over root 2 root 5. And now, of course, you've got the same denominators, so we can just do this as a straightforward subtraction. And while we do it, I'm just going to combine all these surds again. So as I said, you can split the surds up, but you could also put them back together again. So because we've got a root 2 times a root 6, that's exactly the same as just calling that root 12. And that's going to make things a bit easier for us later on. We're then subtracting root 3 and then putting that over, we'll put this back to root 10 now. So remember, root 2 times root 5 is the same as root 10. But of course, now at this stage, we've got the denominator that is a surd. And as you will hopefully remember, we cannot have a denominator as a surd. So we need to rationalise the denominator. And we do that by timesing this by an equivalent of 1. So this fraction, the fraction that we times it by needs to equal 1. It doesn't matter what's on the top, what's on the bottom, it's always the same, so that fraction equals 1. So what we'll do now is we'll times this by root 10 over root 10. So as you can see, this would normally just simplify out to 1 or just cancel it, but it will help us to get rid of this surd of the denominator. So if we times this out now, let's go on to a new line, we're going to get root 10 times by 2 root 12 minus root 3. So yeah, getting pretty complicated right now. And then we're going to divide this by root 10 times root 10. Now, hopefully you'll remember if you times root 10 and root 10, you could just get 10. So if you think about this, if you're struggling to remember that, then if I was to say to you times root 9 by root 9, you would, if you did this sum, you would say, well, that's root 9 is the square root of 9 is 3 times by square root of 9 is also 3. So when you times those two together, you get 9, which is what's under the square root sign. Exactly the same principle when you're doing it with surds. You're just doing it with you're just leaving the root as it is, because we obviously can't do the, well, you could on a calculator, but in your head you can't do the actual root. Okay, so we've now got to this stage where things start to get a little bit more complicated. So the way that I would suggest doing this is we'll just take this top bit. So we've got the bottom, we know that that is what we're trying to get this to equal to. So that's all good, but the top is still looking a little bit of a mess. So what I suggest now is we'll just take this top bit down here and have a little play with that, see if we can simplify it down, and then we'll pop it back over the 10, which is the denominator. So we'll do root 10 times by 2 root 12 minus root 3. Now the way that I would do this is, now if we look at this root 12, we can hopefully simplify this. So if we start by writing out the square numbers down the side, we've got 4, 9, 16. I did miss 1, but that's not normally that helpful with third questions. 25 and 36. And whenever you're doing third questions, I always recommend just putting the square numbers down the side so you can quite very easily see whether any of these are likely to be factors. So now if we go back to this sum, we can see that we've got root 12 here, which we can then separate out into root 4 and times by root 3. And hopefully you'll realise that root 4 is just the same as 2. So we can, square root of 4 is 2. So if we put this all back, we're going to end up with root 10, and then we're going to times that by 2 times 2, which is obviously 4 because it's the 2 from here. So root 4 is 2 times by the 2 that's already here, and then we've got to leave the root 3 as it is, and then we're minusing root 3. Okay. What you're hopefully realising here is we've got 4 root 3 minus root 3. Now, if this is where your algebra principles come in really, really useful, really, really handy. So if you've got 4x minus x, you wouldn't hesitate to say that's 3x. We can do exactly the same with these surds. So we can just simplify this, leave the root 10 as it is, and then we can simplify this. So 4 root 3 minus 1 root 3 is the same as 3 root 3, in exactly the same way you would do it if it was algebra. Oh, I've written I don't know what I was doing there. We've got 3 root 3. So now, if we multiply out this bracket, we're going to get 3 root 3 and then root 10. And then if we go back to what we did originally, we know that if we've got 2 surds multiplied by each other, that's the same as just multiplying and leaving under the square roots. So this is the same as 3 root 30. Now, if we look down these list of Square numbers, we can see that none of these are a square of a factor of 30, which means that we can't simplify this surd any further. But what we do need to do is just go back to this and pop it over the denominator that we had before, 10. So for that, we're going to get 3 root 30 all over 10. And that is in the format that they were asking us to do it in. So hopefully that's made sense. Hopefully you're feeling a little bit happy with surds, having gone through all the different combinations of different, rationalising the denominator, timesing them, dividing them, simplifying them. And I really encourage you to check out the other videos on this channel, and there are a number of them that include surds. So please subscribe to my channel to get the next videos, probably a lot more involving surds. And thank you very much for watching.